You know the area of a rectangle is base times height. So the area in terms of x is going to be the base, which is 100 minus 2x times x minus 6. So that would be a function in terms of x. So now you just simplify it. Distributive property. So that would be 100x. I'm just distributing the 100 minus 600. Oops, I forgot the x. Minus 600. And then minus 2x squared. I'm distributing now the negative 2x here and here. Plus 12x. So put it in the right order in standard form. Negative 2x squared. 100 plus 12 is 112x minus 600. So this is the equation in standard form for the area of the rectangle. Okay, so now for part B. Okay, so I graphed the equation on Desmos. I couldn't screen capture because if I left this video then it would start all over, so I didn't want to start the video over again. But I did give you a rough sketch of what it looks like here on the side. So the x-intercepts are 6, 0 and 50, 0. And this point over here I had to zoom out quite a bit because this point right here is 28. Let me see. So this point over here is 28,968. So that means that when x is 28, the area is the highest. Okay, so that's how you would read this graph. So the x-axis is the length that was bent on the wire, and the y-axis for this one is the area, because that's how we defined our equation. So you get the maximum area when you bend 28 inches on each side to form the rectangle. And in class, if we have time, I'll show you how to use the table function in Desmos. Okay, so 71 through 74 are true and false statements. So for 71, they say that the function f of x has no x-intercepts. So we know that the vertex is 0, negative 1, because again, the k is negative 1, and since there's nothing added or subtracted to x in parentheses, we know that the h is 0. We also know that because the a is negative, we know that it opens down. Okay, so the vertex is at 0, negative 1 down here, and it opens down, so yeah, it's not going to have any x-intercepts. So this one is true. Okay, 72 says that this function f of x has exactly one x-intercept, and again the vertex for this one is 5, 0, because h is 5 and there's nothing added or subtracted here, so k is 0. And so since the vertex is on the x-axis, whether it opens up or down doesn't matter, it's only going to have one x-intercept. So the answer for this one is also true. Okay, 73 claims that f of x and g of x have the same vertex. And when you look at this, you say, okay, yes, they have the same a, they have the same b, right? Both 3's and both 6's. So when I find the x-coordinate of the vertex, I'm going to get the same number. Okay, so their x-coordinate will be the same. But when I plug in that number here and here, and here and here, that same number, well, f of x is going to add 7 to it, while g of x is going to subtract 1 from it. So then the y's will not be the same. So this is a false statement. Okay, this is false. Their x's will be the same, but not their y. So the h's are the same, but not the k's. Alright, for the axis of symmetry, we need negative b over 2a, right? that's what we need. We need to find x equals negative b over 2a. Well, yeah, in this one the numbers are not the same, but look at their ratios, because we're going to be doing x equals negative b over 2a. So 30 over 12 is the same as 10 over 4. So like for f of x, you'll get 10 over negative 8. And for the g of x, you're going to get negative 30 over 24. When you reduce those, you get the same number. So this is going to be negative 5/4, and this is going to be negative 5/4. So this is true. Alright, so for 82, 83, they give you either the maximum or minimum value, and then ask you to find the value of b. So for 82, you're looking, is it for both of them? Yeah, for both of them, you're looking for the value of b. So let's take a look and see what we have. We have the maximum value, which is 48. So I know that this is my k value. This is the c value, and this here is the a value, right? And we're looking for b. Excuse me. Okay, so in order to do that, we need to get this f of x equation in vertex form, and that way we know that the vertex is the highest or lowest point on the parabola. In this case, it would be the highest point on the parabola. But instead of using this specific f of x, let's just start with a general equation for a quadratic. So I'm going to do f of x equals ax squared plus bx plus c. And I'm going to change this to vertex form. Okay, so right now it's in standard form. I'm going to change it to vertex form. Now how are we going to do that? We're going to do completing the square. So this is going to be a good review for completing the square. Oops, square. Okay, so first step, we factor out the a from the first two terms, because since these are the terms that have the x, I'm going to work with those two and kind of keep the c by itself, keep it outside, okay, outside of the loop. So I'm going to factor out the a, because remember, for completing the square, the x squared term has to have a 1 in front of it, so we don't know the value of a in general, so I'm just going to factor it out. So now I have x squared plus b over a, because I factored out the a from both terms, and so now I have plus c over here by itself. Now remember the rules for completing the square. We take this term, cut it in half, and square it. So we're going to take this term, cut it in half, and square it. So that's going to look, I'll put it here on the side, 1/2 of b over a, okay, and then we're going to square it. So that's going to be b squared over 4a squared. So I'm going to change the color, I'm going to add b squared over 4a squared, and since I added it, I have to subtract it, because I can't change the actual function. If I add anything, I have to subtract it. But what did I really add? Since I put it inside the parentheses here, notice there's an a out here, so this gets distributed to this one. So I actually only added, so I put here, I added b squared over 4a, not 4a squared, because this a will cancel with one of these, okay, when you distribute the a. So I actually just added, even though I wrote in a squared right here and inside parentheses, this is what I actually added, okay, because I've got to take this into account. So that means that I have to subtract b squared over 4a, okay? So that what happens by doing this minus b squared over 4a is I have not changed the original equation at all. Because what I added here, taking this into account, I subtracted here. Now why do all this? Because now I can factor this that's in the parentheses, and I will now have it in vertex form. It's going to be a very messy looking vertex form, but nonetheless it is vertex form. So going back to the equation, this would be x plus, now the square root of this is b over 2a squared plus c minus b squared over 4a. So now this is my k and this is my h. Okay, so there's my vertex form. So now I'm going to use what I have, what I know, what I identified up here as my a, my c, my k, to find the value of b. So I'm going to use this part. Notice how I have c, a, and I'm missing, and then I know k, I know what the value of this whole expression is right here, and that's going to help me find b. Okay, so we're almost done. So I know that c minus b squared over 4a equals k. And so c for this problem is negative 16. A for this problem is negative 1. And k was given to you as 48. So I'm going to, step by step, solve for b. So first thing I'm going to do is I'm going to add 16. And then right here, this negative and this negative, because we're doing 4 times negative 1, cancel. So I have b squared over 4 equals 64. So I'm going to multiply by 4. Okay. And I can multiply 64 times 4, or I can just say, okay, I'm going to take the square root of both sides. And so I get b is plus or minus 8 times 2, because the square root of 64 is 8, the square root of 4 is 2. So then that means b is plus or minus 16. And so, boom, there it is. Now why 2 answers? Because remember, all we know is that the y-intercept is negative 16, right? That's your c value. And you have a maximum of 48, so let's say that 48 is up here. So we don't know if the parabola is going this way or whether it's going this way. So that's why you have the plus or minus 16. Alright, 83 will go a lot faster because we're not going to go through the whole process of completing the square. We already did it for 82. So we know that this is the c value. We know that right here is the a value, and this is the k value. So we know that k equals c minus b squared over 4a. So 10 equals 26 minus b squared over 4 times 1. So I'm going to subtract 26. So that's going to give me negative 16 equals negative b squared over 4 over 4. Okay. And so I can multiply by negative 1 both sides, so I get that. And I could multiply by 4. So then I have b squared equals 16 times 4. And because I know that 16 and 4 are squares and I'd rather keep the number smaller, I'm just going to take the square root as they are, like that, without multiplying. So I know that b is plus or minus 4 times 2, because square root of 16 is 4, square root of 4 is 2, and so b is plus or minus 8.